So now we're going to be looking at the Unit 2 part of the final review. So in Unit 2 is where we dealt with segments and angles and first introduced proofs. Now the first type of proof that we looked at was an algebraic proof. Still the same process. So we have our two columns, we have our statement column and our reason column. So, just like any other proof, we write down our given statement. So in this case, it's an equation. So 4 parentheses, 3x plus 2, close parentheses equals 44. And that is given. Now for the algebraic proof, we're just going to state what we did to solve. So, first thing that we have to do to solve is distribute. So that's 4 times 3x, which is 12x. And then 4 times 2, which is 8, equals 44. Once again, we distributed, so that's our distributive property. The next thing we need to do is get x. Well, start getting x by itself. So we're going to subtract 8 from both sides. So I get 12x equals 36. That was our subtraction property of equality. And then last but not least, we divide both sides by 12. So our last statement says x equals 3. And that is our division property of equality. In number 2, it says find the value of y. Explain your reasoning. And when we say explain your reasoning, it's how did you know how to set up the problem? So we have an intersection, and we look for the spot or spots that have a y. Well, have a y there, have a y there. That relationship between those two angles are vertical angles, so that's going to be my reason. And I know vertical angles are congruent, so I can say 13y equals 10y plus 24. So I'll subtract 10y from both sides. So 3y equals 24. And I'll divide 3 from both sides. Y equals 8. So now we have proofs. Our first proof is given 2 pairs of complementary angles, prove that A is congruent to C. So with just like any other proof, I'm going to write down my first given. So angle A and angle B are complementary. Now glancing ahead a tiny bit, I see another pair of complementary angles. So I would deal with this vocab word of complementary, but because we have another set of complementary angles, we might be able to set things equal. So let's write down our second given. Angle B and angle C are complementary. Good. And now something that I notice in both of these given statements is they both have angle B. So since they both have angle B, since those parts are congruent, the other parts have to be congruent then. So I can say angle A is congruent to angle B, because that is what's called congruent complements theorem. And looking, that is actually what we're trying to prove. I meant to say angle A and angle C. Next one is a fill-in-the-blank proof. So I notice that there are 4 blanks in this. And my first 2 reasons say given, so I know I'm going to have to write down my given statements. So the first one says segment BF bisects angle AFC. And then my other one says angle CFD is congruent to angle BFC. And now looking at my third statement, it says angle AFB is congruent to angle BFC. Now looking, that is the 2 halves of angle AFC. And looking back up at our givens, we had a vocab word. So this must be then definition of that vocab word, the definition of bisect. Now at the bottom, it says angle AFB. Well, we said that already. And then angle is congruent to angle CFD. Said that already. Well, looking at those 2 spots that we said it, they both have angle BFC. So in other words, we are plugging something in. So this has to be our substitution or transitive property of equality. Looking at number 5. Prove the vertical angles congruence theorem. We did do this one in our notes. But we're going to do it again. And possibly do it in a shorter method. So remember, since we're proving the vertical angles are congruent, we cannot say automatically that angle 2 and angle 4 are congruent. So I can say angle 2 and angle 4 are vertical angles, because that is given. So then looking at our diagram, I'm going to see if there's any other relationship. So I notice that angle 2 and angle 3 make up that line. They're a linear pair. And I know linear pairs are supplementary. So I can say angle 2 and angle 3 are supplementary, because they are a linear pair. Well, not only are angle 2 and angle 3 a linear pair, angle 3 and angle 4 are a linear pair. Meaning angle 3 and angle 4 are supplementary as well. So we did end up saying supplementary twice. And in fact, in both of those statements, we said angle 3. So if those two are congruent, the other two have to be congruent. Just like how we did on number 3. So we can say angle 2 is congruent to angle 3, to angle 4. Because of congruent supplements theorem. And that is what we're trying to show. Both of those are congruent. So now we have some vertical angle stuff. Remember, the vertical angle stuff was the second half of Unit 2. So remember, when we can say two lines are parallel, we can use alternate interior, alternate exterior, corresponding, and same side interior. If we don't say that they're parallel, those four are locked. We cannot use them. Well, fortunately, our first given says parallel. So G is parallel to H. Given. So G and H are parallel. So what this means, before we go any farther, is this kind of is a vocab word. As soon as we say parallel, we can say any of those relationships. But we need to figure out which of these two lines is our transversal, either the P or the R. Well, if we look at R, there's only one angle on that intersection of the parallel and R. So that's not going to be helpful. We need at least two. Well, if we look at P, we have two angles on there. So we can say whatever that relationship is. So I can say angle 1 is congruent to angle 3 because those are corresponding angles. So treat the parallel like a vocab word. As soon as you say parallel, figure out what transversal you're using and what relationship. So then I can go on to my next given. It says angle 1 is congruent to angle 2. Given. In fact, in statement 1 and in statement 2, I have angle 1. So that then tells me that angle 2 has to be congruent with angle 3. Because that is our substitution or transitive property of equality. Well, unfortunately, we're not dealing with just proving this relationship. Our proof statement is proving two lines are parallel. So as a reminder, we need to use a converse statement. So I know part of my reason 5 is going to have the word converse. So then what is the relationship between angle 2 and angle 3? Well, those are corresponding angles. So our reason is going to be corresponding angles converse. So because we use the converse, we can say P is parallel to R. Looking at number 7. Now the proof. This one is a longer one. So, looking at it, we have 2 given statements. Our first given statement says A upside down capital T B, or in other words, A is perpendicular to B. So, looking at your given, do we have a vocab word? In this case, we do. We have perpendicular. So I know my next reason is definition of perpendicular. Well, then perpendicular, I know, means 2 lines or line segments that make right angles. So I can say angle 1 is a right angle. Well, we still have a vocab word. Now our vocab word is right angle. So I know my next reason is definition of right angle. So I know right angles mean that they are equal to 90 degrees. So the measure of angle 1 equals 90. Now I want to put a little mark off to the side because I can't go any further with that, and most likely we're going to have to come back to this. So then 4. We have another given, so let's say our given. B is parallel to C, given. So we said parallel, meaning it unlocked those relationships. So let's look and see what relationship is being shown. Angle 1 and angle 2 have to be congruent because those are corresponding angles. Now, we don't have any vocab, but if we look at where we left off on statement 3, we have an equals. On statement 5, we have a congruent. Cannot combine the two. But I can switch a congruent to be an equals. So I can say measure of angle 1 equals the measure of angle 2. Remember, whenever we go from a congruent statement to an equals, it is definition of congruent. So that's where we left off. We can combine those two. If I know the measure of angle 1 equals 90, and that the measure of angle 1 and the measure of angle 2 are equal, I then know that the measure of angle 2 equals 90. That is substitution or transitive POE, property of equality. Well, what does it mean for an angle to equal 90? Well, that must mean then that angle 2 is a right angle. And that is definition of a right angle. So then what does it mean when we create a right angle? Well, those 2 lines or line segments have to be perpendicular. So I can say A is perpendicular with C. Definition of perpendicular. So for 8, we need to find the value that makes M parallel to N. Now, we just said that makes parallel lines. as well as it says converse. So our reasonings that we are going to use have to be a converse statement. Well, if we do our highlighter trick and highlight our zigzag, same color means we set equal, different colors add to 180. Well, these two are the same color, so I can write 4x equals 6x minus 44. So we normally like to get rid of the smaller x first. In this case, it's not going to be helpful in the long run to get x by itself. So I'm going to get rid of the other one. I'll subtract 6x from both sides. So I get negative 2x equals negative 44. Divide both sides by negative 2. X equals 22. So we did the first part. We did the second part. We found the x. We need to state our reasoning. The relationship between those two angles are alternate interior angles, but we need to use the word converse. For the second one, once again, we can do our highlight trick. Same color, set equal, different colors add to 180. So these are different colors. So I know x plus 20 equals 180. Combine like terms, I get 2x plus 20 equals 180. Subtract 20 from both sides. 2x equals 160. Divide by 2. X equals 80. But we need to state our reason again. Both of those angles are inside of our parallel lines, so this would be our same side or consecutive interior angles converse. C. Once again, highlight trick. Same color, set equal, different colors add to 180. These are the same color, so we set equal. So x plus 1 equals 110. Subtract 1 from both sides. X equals 109. Our reasoning is corresponding angles converse. Now, just like the vertical angles proof, we cannot use the alternate interior angles theorem. We cannot use alternate interior angles in its own proof. So, let's start off like we normally do with our given. P is parallel to Q. That right there unlocks our relationships, but unfortunately, alternate interior is still not usable. So looking at this, we're going to state what relationship. Well, since we can't use 1 and 2, could use 1 and 3. Angle 1 is congruent to angle 3 because they're corresponding angles. In fact, looking at it again, I see another relationship. This one is angle 2 and angle 3 have to be congruent because they're vertical angles. So I just said angle 3 twice. Angle 1 is the same thing as angle 3, and angle 2 is the same thing as angle 3. So angle 1 has to be congruent to angle 2 because of the substitution or transitive property of equality. For 10, not problem 110, problem 10. What postulate or theorem proves that A is parallel to B? Well, we have congruency marks on this diagram. We have one there, and we have another one there. So that relationship between them would be not alternate, they're corresponding angles. But keep in mind, we're proving lines parallel, so we have to have the word converse. So it's corresponding angles, converse. In B, once again, we have two congruency marks between those two angles. So that would be our alternate interior angles. Once again, converse. In problem 11, it says find the value of x, then state the postulate or theorem that supports your answer. Now notice on how both of these have those arrows, meaning we already have parallel lines. We are not going to use a converse statement. So we can do our highlight trick. Same color, set equal, different colors, add to 180. So in this first one, add to 180. So 2x plus 68 equals 180. Subtract 68 from both sides, and we'll get 2x equals 112. Divide both sides by 2. X equals 56. So we found x, we need to state the postulate or theorem. Those two would be same side or consecutive, interior angles. B, highlight trick, same color, set equal. So we can write 2x minus 4 equals 92. Add 4 to both sides. 2x equals 96. Divide both sides by 2. X equals 48. Relationship between these is alternate exterior angles.